In this video, I'm going to talk about scientific notation in general, and then we'll get into converting numbers between scientific notation and standard form. So to start, just general knowledge about scientific notation. Scientists really just use this as a way to express really, really big numbers and really, really small numbers instead of having to write out all the zeros that would be involved with those kinds of numbers. The basic equation for scientific notation is capital N times 10 to the little n. So the capital N is called the coefficient, and that is a number that is between 1 and 10. So anywhere from 1.0 all the way up to 9.99999, okay? And then the times 10 always stays the same, and then the little n is an exponent of 10. And that can be positive, it can be negative, it can even be 0. If you see a times 10 to the 0, that just means times 1. So really, in standard form, it's just the coefficient. FYI. So we are going to break up numbers written in scientific notation into those that have a positive exponent and those that have a negative exponent. So we're going to start with positive exponents. We use positive exponents to express really, really large numbers, or really any number that's greater than 1. Okay? It also represents the number of times that you are going to multiply your coefficient, or capital N, by 10. So for instance, 3.7 times 10 to the third is really saying that you are going to multiply 3.7 by 10 3 times. And common sense would tell you that when you did that, it would be a rather large number, okay? It also represents the number of places that the decimal is moved to the right when going from scientific notation into standard form. Standard form is really just the regular way that you write numbers. So if you were to write out the number 3,500,004, the way that you would normally write it out with commas and writing all the numbers out, that's standard form. When you have a shortened version of that number times 10 to an exponent, that is scientific notation. Okay, and we can go back and forth between the two. So if we were given these two numbers in scientific notation, it's very easy to figure out the number in standard form just by moving the decimal. So if we were given 3.50 times 10 to the second, this positive exponent is first off telling you that we are moving the decimal to the right, okay? And the number of spaces that we are going to move it to the right is determined by the value of the exponent, okay? This is a 2, it's a positive 2, so we are going to move this decimal 2 spaces to the right, okay? Like you see here, 1, 2. So the decimal is now after the 0 to get us this answer, 350. That's standard form. The second example I have is 7.71 times 10 to the fourth. This positive 4 exponent means that you are moving the decimal 4 spaces to the right. So we move it 1, 2, 3, 4 to the right. But you might be saying, Ms. Key, there's empty spaces here. You always fill the empty spaces with zeros, okay? So that's where these 2 zeros came from. They were put in this empty space, okay? So you would get the number 77,100 as your answer. Let's move on then to negative exponents. It's basically the same thing reversed, right? We use negative exponents to express small numbers, or really any number that's less than 1. It's also the number of times that you are going to divide your coefficient, or capital N, by 10. So if we have 5.5 times 10 to the negative fourth, we are going to divide 5.5 by 10 4 times. Common sense would tell you that would be a rather small number if you were to calculate it out. It's also the number of places that you move the decimal to the left. So let's go into some examples. If we have 9.80 times 10 to the negative second, this negative 2 exponent is telling you that you are moving the decimal to the left 2 spaces. So when we move this to the left 2 spaces, the decimal is now here, and we fill this empty space with a 0 to get the answer of 0.0980. Down here we have 4.11 times 10 to the negative third. This negative 3 exponent is telling you that we are going to move the decimal 3 spaces to the left. So we go 1, 2, 3. Your decimal is right here. And now you fill these empty spaces with zeros to get 0.00411. Okay, so that's going from scientific notation into standard form. Now, we can also go from standard form into scientific notation. So the way that we convert numbers from standard form into scientific notation is simply by moving the decimal either to the right or the left until there is one digit between 1 and 9 to the left of the decimal. And then based on the number of spaces and the direction that you moved, that is going to determine your exponent. Okay, so this bullet here is telling you how to get your capital N in that general equation on the first slide that I showed you. And this bullet is showing you how to get the little n. I have a blue box here that is helpful information. If your number in standard form is larger than 1, or if you move the decimal to the left, your exponent is going to be positive. If your number is smaller than 1 in standard form, or you move the decimal to the right, then your exponent is going to be negative. So let's try one. Let's say that we have a number in standard form of 10,750. Now, if there is not a decimal in the number already, you are free to assume that the decimal is at the very end. So we can assume that the decimal is right here. We are going to move this until there is one digit between 1 and 9 to the left of the decimal. That means that we need to move the decimal to the left, and we need to move it to the left 1, 2, 3, 4 times. Okay? If we are moving the decimal to the left, that means our exponent is going to be positive. So in this case, if we moved it 4 to the left, it will be a positive 4. You can also see that our starting number was larger than 1, and that can also tell you that it should be a positive 4. So you would write this out as 1.0750 times 10 to the 4th. Let's try another one. Let's say that we have the number on the screen. I don't want to say all those zeros. We need to start by moving the decimal either to the right or left until there's one digit between 1 and 9 to the left of the decimal. In this case, we are going to move it to the right. 1, 2, 3, 4, 5, 6, 7 spaces. Okay, we can't stop here because there would not be a number that's a non-zero number to the left of the decimal, and we can't go one more because that would be too many digits to the left. We have to stop between the 1 and the 2. And since we moved the decimal to the right, that can tell us that our exponent is going to be a negative 7, or the fact that our number in standard form was smaller than 1 to begin with will also tell us that our exponent will be negative 7. And then our coefficient is 1.27. Okay, that's scientific notation and how to go between standard form and scientific notation.